and all of that after we come back. And actually, I'm going to have to pause my recording, I just realized, because we are going to get back to doing Name Your Numbers, which we had been doing when we were just on Zoom, and then I got away from it when we came back. But we'll do that right after announcements. So your work in Khan Academy is due Wednesday. I accidentally set it to AM. It's not AM. It's PM. Guys, if you don't have graph paper out yet, please get some out and come borrow some if you need, and come take some from my drawer if you need it. If you do work in Khan and you need grades updated, just email me. Or if you have questions, just email me. Mastery is going to deal with percent change and like tax and tip and like restaurant type problems. So that's why we're going to save the Desmos game probably for Friday, because I'm writing the Mastery and I know exactly what I'm putting on it. And LearnStorm goes till the 22nd. The winning class will get something. I don't know what it is yet. Please don't ask me. It'll probably be like donuts or something. It's probably food. Food's the easy thing to do. I mean, I could get you all like a cool pencil, but I think you'd rather have a donut. So yeah. Natalie's like, yes, donut. Forget the pencil. Stella. It's the thing we're doing in Khan Academy. The thing with the levels and the candy. And that you were sick, I think. Maybe I owe you candy. Somebody explain what LearnStorm is.
I don't know what LearnStorm is.
We've been doing it. It's the thing.
I wasn't in class last week. I wasn't in class last week, so I don't know either.
Wait, LearnStorm ended. They lied. No, you have until November 22nd.
What is LearnStorm?
Oh, I might not be able to assign anything more. This might not be good. So, this is LearnStorm, the thing with the levels that we would check. This is LearnStorm.
I have never in my life done that before.
You don't do anything special. It's when you just do Khan Academy, it counts towards our LearnStorm.
How do you check it?
I do. You can't. So you just do your assignments. Guys, we talked about this a long time ago, or you maybe never watched the video thing. 3 assignments per person fills a level. So when each of us does 3 assignments, we fill a level. You don't do anything special. You just do your work in Khan Academy. But there's no time to check that right now. So let's do Name Your Numbers. I am going to pause the recording to talk about who this actually is. But this information is about somebody in your class. I need to find the pause. All right, so if you want to ask her anything else about that, you can, socially distant, of course, chat outside of class, at lunch or whatever. So guys, I bought a new tire pressure gauge over the weekend. Thanks. Because it's getting cold outside, and you got to check the tire pressure in your car tires to make sure everything's safe. And on the back of it, it read, I can't make this up, guys. This is a picture. Look, the cardboard was bent. You can improve your gas mileage by around 3.3% by keeping your tires inflated to the proper pressure. Underinflated tires can lower gas mileage 0.4% for every 1% PSI drop in the... So, guys, percents, right? Percents are everywhere in the world, but these percents are kind of scary and a little difficult. So, let's look at some of the percent problems that we're dealing with and see if we can build any new formulas. So, a spider ate... let's go ahead and head our notes, just like percent problems, or like solving percent problems, or whatever you want to kind of make your header. Oh, you're doing purple too? It's not a good purple? I'm very sorry. You chose it. Well, I mean, you bought it, right?
Actually, I didn't. It came for free in Sketchbox.
So, where is the thing I need? Go ahead. I can't find the tab I need. Whoa! We do not just jump to answers. We talk about how we get the... I'm, like, taken aback that you would think that that's appropriate to do in my class. I'm extremely offended. I would think Lacey would know better. Lacey, that's like insulting me personally to just jump right to the answer. Lacey, I will give you a chance to recover and redeem yourself and tell me how we can solve this problem. Because we know we don't just want the answer, we want the process. So how can we deal? Because the other thing is we want to make some formulas that'll work in any situation. So I'm going to label this problem bugs. And remember, some of you haven't done these homeworks yet. This is a problem straight from your homework. You may get this problem, you might not get this problem, because remember, I randomized them this time. Lacey, how do we solve things like this?
If 8 is 100%, because that's the full amount, then 25 is pretty much 1/4 of 8. 8 divided by 4 is 2.
Oh, so you sort of did this proportionally. You said 8 bugs is 100%. And then you said, I'm going to scooch this up a little bit, that 25%, and guys, it wouldn't matter how I would set up this proportion. I'm just drawing a picture to match what Lacey told me, is like 1/4, right?
Yeah.
Times 1/4 or times 0.25. So what's 1/4 of 8? Well, that's 2. So now, I 100% agree. But remember how we're using our calculators now, and this test will be a calculator test? I wonder if there's a way that we can just make a formula. So what I have up on the screen is, can we build new formulas to solve percent problems? If we want to build, and guys, this is where I would use your separate piece of paper. I put on the screen that you might want to have 2 pieces of graph paper out. Let's label a piece of graph paper, and we're going to use this for a while, right? So if you don't have a second piece, please just come grab one. We're going to label this formula sheet. I'm going to say Math 7 so I can remember which class it's for. And then I'm going to make this section percents. We did one last week that was percent change. So we should go ahead and copy it over to here. We only practiced it one day, so you may not remember it. On that day, I think I taught you about the triangle being like delta, meaning the change in.
Is that why they call it Delta Airlines?
I wonder. So delta is a Greek symbol or a Greek letter. It's used for a lot of things, but yeah, that would make sense because Delta Airlines changes where you are, right? So that would make sense. Percent change is the amount of change divided by previous or the original. And then we do times 100 just to get it to percent form. So that's why I write that times 100 kind of small. Now, we are not solving for percent change here. They tell us the percent change. They tell us the percent change is 25. So I'm going to put this in a little box. That's a useful formula. And we actually kind of did that one last week. If you don't remember it, I might be making this up. We maybe didn't do it last week. Because remember, we have blue-green days and I get a little confused every now and then. But there's our formula for it. We'll apply it today, don't worry. What we did in the bug problem is to figure out the new amount of something. To figure out the new amount of something, we did this last week. We want to do some math that we could actually do in a calculator and utilize percentages, right? How could we find a new amount using percentages? In these percent change problems, do we know a new percent? Like Lacey, in this problem, you said we went up by 25%, but what does that mean we have in total? 125. So if we use the new percent multiplied, yeah, now you could say old, but previous is kind of a nicer word. Doesn't make me feel bad about my back hurting really bad today. So if we come over here and apply that to our bug problem, sorry guys, I'm just going to full screen. the previous amount of bugs, right? So 8 is the previous, is what they tell us. 8 is the previous amount. And we go up. Sorry, my G's are a little weird. I know. Yeah, that's, sorry, it's, my pen gets stuck sometimes because the metal tip, so sometimes they look even weirder. So our formula here would be that the new amount of bugs will be equal to, now wait, can I just put 125? No, we have to put it in what form? Ooh, careful. Decimal form, right? So we got to change it from percent to decimal, so it's actually 1.25 times 8 times that previous amount. So the new is one. Now, if you don't have a calculator, guys, like in your backpack or whatever, you can borrow one of mine, and I might grab them and walk them around, so we don't all just go back there by Martin. But when they tell us that we go up by 25%, 8 was the previous, we just multiply 1.25 by 8, and we get the same thing that Lacey got. We get 10 bugs. Now I'm thinking I don't want to do the next problem next because, yeah. We're going to do this problem with Kong and Nolan next.
That is an unfortunate name.
Nah. If I have a kid, you better believe they're going to be named something sweet.
Like Kong? Like
Kong is a type of
I-
dog toy.
Yeah,
I will
it's a
say-
dog toy.
I will say-
No, that's a bomb. Same thing.
All right, moving on. So Kong took 15 fewer seconds than Nolan to complete his multiplication time test. Kong took 85 seconds. So guys, these percent problems start to become tricky with how do we set it up. So take what they tell you verbally and set it up mathematically. Kong took 15% fewer. So Kong was, or is, I guess was because it was past, 15% faster, right? Kong was 15% faster. Ooh. But I think Lacey's already analyzing what that means we're going to do. Stop. You just keep shouting out answers. We want processes. What's our process to get there? Since Kong was faster than Nolan, if Nolan is our 100%, then Kong is 85% of Nolan. Because, as Lacey said, if we take 100% and minus 15%, now, this is new equals percent times previous. Now remember, we can't actually use the percent. We use the decimal form.
Why?
But. So I should not have written this down with n being new. Because check it. Instead of doing that, I'm going to say Kong is 85% of... Huh?
Why do we have to turn in the decimal?
Because percent... Thank you for that question. Percent means per 100. So 85%, if I'm not using the percent symbol, which we cannot do the math with the percent symbol in here. Like, we can't do the calculation. We literally have to put it into decimal or fraction form. So if we put it into fraction form, it's 85 over 100. We could use that, but if I'm going to type it into a calculator, it's easier to type 85 hundredths this way. All of these numbers are equal. These are all the same numbers. So that's one of the things that we have to remember is like, I didn't change anything. I just wrote it with a different representation. So 0.85 times n. Here's where this gets tricky. And guys, I would use their names like Kong and Nolan so you can remember when you like are in Khan Academy. I know some of you haven't done this homework yet, and the questions are randomized. You might get this question. Do they tell us Kong or do they tell us Nolan? Man, we're used to when they tell us the previous, right? Now they tell us the new result. So if they tell us Kong, that's the new result. So 85 seconds, we can label if we want, is equal to 0.85 times the n. For Nolan, right? This is Nolan. Really, it's Nolan's time. Last week we said, what do we do to get rid of a division? What do we do to get rid of a multiplication? There we go. My brain was ahead of itself. You ever go to ask a question and you say the answer instead of the question?
Sometimes I try to say sentences and only one word.
Yeah, it's...
I'm going to my house today. And I just come out, house. Sometimes I try to talk too fast and then I just end up gibberish.
So, guys, this is where Khan Academy is going to start to frustrate you. If you... Sorry, sometimes when us teachers pause, it's intentional because we think we've lost a couple of you and we're trying to change up the cadence of class to bring your focus back. We're used to the pattern of get a percent, multiply by the other number they give us, get the new number. Great! But that pattern changes depending on if they give us the new number or the previous number. They talk about Kong and Nolan, but then they give us Kong. And Kong's time is the modified time, or the new time. So we're actually kind of going backwards, in a way, to solve this equation. If we divide, we will get n by itself, right? This side, Nolan was n. So we'll get 1n, because remember, this makes a giant 1. I know you don't want me to say that, but it does. And oh, well, that makes sense. 85 divided by 85 hundredths is 100. That makes sense, because this is 100 times bigger. And what was our label here? It was seconds. And guys, we can always flip an equation around. So I'm going to flip this around, right? N equals 100 seconds. We can always take what was on the left and put it on the right, and what was on the right and put it on the left. So I just flip it around, put the n on the left, the 100 on the right. Hold on. Hold on, and then do what? Hey, Isaiah, you with me, man? Because I don't know if you can write faster than me, but every time I look up, I don't necessarily see us writing. Now, always, like, and I haven't checked Khan Academy to know this, but if Isaiah said, yeah, I already did this problem, like, I already did this homework and I'm good, then I'd be like, all right, man, fine. Like, I know that you guys can work ahead of me right now because of Khan Academy. Some of you are choosing to get ahead of me, but most of us, I think, come to class and need to see these problems and need to write it out with me. So Isaiah, for real, like, if you've already done this in Khan Academy, I know this is like the weird Phoenix switch, but that's just being honest with me. It's not being disrespectful to tell me I've already done this. I don't need to write this down, but I hope that's honest. So, like, if any of you, I call you out, like, hey, why aren't you writing this down? Like, you can tell me, hey, I already did this, but hopefully it's honest. Any questions up here with Kong and Nolan? Yeah.
How did we get 100 seconds?
Calculator. We did this division in the calculator. Okay. So at this point, I'm assuming the use of calculators, guys. I'm assuming you will grab a calculator to solve these problems. Or use your computer calculator. I like the handheld calculators better, though. If I was you, I would keep a handheld calculator in your bag. If my backpack was bigger, I would keep one in it, but I keep like one of the fancy ones under my desk and one on my desk at home. So I always have a calculator right in reach.
Mine is right.
Perfect. Perfect.
So no phone.
Yeah, no phones. Because you could just Google. You could pull out that stupid, like, solve my math problem app and just use that, which is only sometimes accurate. I would not trust it. Finley's pumpkin had a mass of 6.5 kilograms. This is sad. We used to do a pumpkin lab, and we would, like, gut the pumpkins together, but now that would not be socially distant right now. Guys, we're just keep holding your breath for that vaccine. They're doing trials. They're trying to get it moving forward. Yeah, they're like 90% effective so far. So after carving it, the pumpkin had a mass of 3.9 kilograms. What was the percent decrease in the mass of the pumpkin? So guys, if we went back to our formula sheet and we're like, oh, what are we doing here? Are we trying to calculate a new value? Are we trying to calculate a percent change? What are we trying to calculate? Well, this is a percent change problem, right? So the formula that we're going to use is not the one I'm putting in the box, but is this one right up here. The percent change, whether it's increase or decrease, change means up or down, right, is the amount of change divided by the previous times 100. Hey guys, I'm going to tell you right now, there will be tests where I say you cannot use your notes, but you can use one, like the formula sheet. Okay, so like you wouldn't be able to use the notes, but you'd be able to use your formula sheet. And I'd come around and check, like, is it just formulas? Because I might reuse the same problems, and I don't want you to just copy what we've done. But formulas you can use, so please make sure that you're, like, keeping a formula sheet. You can always come ask to see mine and see what's on it, but, like, now this is kind of like our formula cheat sheet, if you will.
How do you spell formula?
Form like a form you fill out. Like ULA. So they tell us the original. I'm gonna change colors just because I'm like writing over here now. The pumpkin was original or previous was 6.5 kilograms. The new weight is 3.9. And they want us to answer the percent change. Well, how could we figure out the amount of change? What kind of math? How do we figure out change? Yeah, subtraction. Thank you, Natalie. So to figure out the change, we're going to do a subtraction up here. So the original minus the new, since that would give us big minus small. Right? We're going down. How much did we go down? 6.5 minus 3.9. Now, this is the dangerous part. Which of those numbers goes on bottom? 6.5, because that was the previous. Remember, the previous value goes on the bottom. So the 6.5. And then we will times 100 at the end of all this. 6.5 minus 3.9, well, I can think 65 minus 39. So 1 takes us to 40, 50, 60, 21, 26, or 2.6, I believe. And this is when we grab our calculator, right? 2.6 divided by 6.5 0.4, but then the times 100, and here's all that times 100 does. It does that swoopy swoop with the decimal. Yeah, it moves it 2 spaces over and becomes 40%. Swoopy swoop move. Oh, I love that. That's mine, the one that I have at home. Like, at school, it's the pink ones because they're the school ones, but I have that gray one at home. Guys, I gotta tell you, I just have to say it out loud. when I look at you guys, especially Natalie, I can see the reflection of the stuff behind me, and since there's a duck behind me, every now and then right beside your head, I can just see the reflection of a duck, and it looks like there's a duck floating, like, right beside you. It's real funny. Like, from back here, it just looks real funny. So you have, like, a duck, like, right here, Natalie. Just imagine this. We gotta give him a name. What should his name be?
No, we need a
All right,
better
well,
name.
let's talk about this Wednesday. I don't want the first name that comes to your head. Think about what would be a really good name for a duck. Don't say Daffy. That's been taken. John Stanell.
Donald Trump.
No. Actually, I think the expression looks like a duck, talks like a duck, walks like a duck has been used. All right, try this question about the swimming pool, although I might give it its own page now that I have actually done this kind of in a different order than what I anticipated.
Oh my God, Donald Duck. Donald Duck. No.
All right, try this. No talking for just a moment, please. This is a real issue that outdoor pools have. Water evaporates. Not in a pool because it's like, I mean, if they pump it in, yes. But like it doesn't just happen on its own. So I would write down the original, I would write down the new, right? We just did one of these problems. And guys, you can make your formula sheets like as nice as you want. So on your at-home days, if you want to decorate them and like color code them or whatever, we'll start to fill that formula sheet with more stuff. Original. Oh, sorry. I did not mean to cover up stuff. What? That I covered things up?
Yeah, now I can see it. What am I solving?
Change, decrease. So we're just trying to figure out change. What is the percent change?
7.
So since they're both in million, we can kind of ignore the million. Because think about it. If you do like the subtraction, your label is still going to be million. Everything we deal with here is still going to be million. So just ignore the million. Let's say 2.5 to 2. Right? So if our original is 2.5 and our new is 2, and we want percent change, well, remember it's change divided by previous. How do we figure out our change up here? Natalie, you told me last time. Subtraction, right? Change is going to be found by subtraction. 2.5 minus 2. What goes on bottom?
2.5.
The original, the previous, right? In this case, the 2.5. So that will give us 0.5 over 2.5. And when we do that division, well, I can tell you right now, this is like 5 over 25. So if this was 5 over 25, that's a fifth. And a fifth is 0.2. So wait, it's 0.2%? Ah, we have to still multiply by 100. Is that last thing that we do. So multiplying by 100, that does the swoopy swoop with the decimal. We have to add a 0 on the end. And we get 20%. Ooh, decrease, right? That's not good. I can't spell. It'd be a 20% loss, right? They lost 20% of their water. So that's a big expense, right? If that's like a daily thing, maybe that was over a weekend. Who knows? But is this making sense? Let's try another one.
I mean, okay. Every single question on this is not entirely.
Yeah, I want to get to some tax problems, but let's do one more just with things that are not money. In Magic Club, there are 20% more goblins than wizards. So, goblins are 20% more than wizards. Nate?
One of the videos are about this.
Oh, the con videos?
Yeah,
Yep, probably. Why? Because she doesn't like goblins and wizards?
She's very Christian.
Yeah, my grandma was too.
And it's against our religion. Why do you say like our religion? I don't know.
Guys, this one comes down to setup. So, when we go to set this up, I have to start a new paper because my other paper got filled up. Which has more, goblins or wizards? So, goblins are, right? Goblins are equal to 20% more
Oh my god, I just spelled more wrong.
than the wizards. Oh, I didn't even put the word more.
The goblins are 20% than wizards.
So wait, 20% more. What does that mean the actual percent we're using is going to be? If it's 20% more. 120%. So goblins are, sorry, I'm going to throw a pen down here or something so it stops refocusing. 120% times the number of wizards. That reminds me, I think Dave left his wizard in my basement. A friend of mine was storing some things at my house, like things that were breakable, and he has a wizard that is made out of like stone or something like that. That's like, because he wanted it for his game shelf. So as an adult, sometimes you just buy stuff because it's a decoration. Now wait, oh crap. They don't tell us wizards. Remember how we're used to the problems where we plug the number in here? What do they tell us? Goblins. So where do I put the number of goblins? In for G, right? They told me the new amount here, essentially, right? So since they tell us goblins are 120, and again, some of you might have this problem in your con. It is randomized. Now wait, can I use 120 with the percent sign? No, so we do a little swoop-de-swoop. And this is 1.2, and I can put that extra 0 if I want to remember the little swoop-de-swoop that happened. I'm going to draw a little reminder for myself. That's why I started using the thicker lead. And then wizards, I'm going to change that to W. Natalie, you can tell your grandma I'm sorry, and I did not write that problem. I will keep wizards off of my test. I know, I'm just... My grandma was the same way. I wasn't allowed to tell my grandma that I played poker.
I'm not allowed to tell show my grandma magic tricks.
Yeah, because magic is, yep, same. My grandma passed away a few years ago, but it sounds like they were pretty similar. So, if this is being multiplied... Sorry, we're running out of time, so I would love to tell stories, but I got to do a couple more math problems. Since this is multiplied, we want to divide, and we do 1.20. Oh, this is going to give us another situation where it comes out nicely to 100. So I get 1W because I stacked a number on top of itself. Sorry, this is my 1. I make them kind of fancy so I can tell that they're not an L. And then this comes out to just be 100. So there must be 100 wizards in Magic Club. No, because we cannot do subtraction. We're not allowed to subtract on the two sides. We can only multiply or divide.
Wait, don't we flip that around?
What do you mean?
Like the 100 and the like last two columns, we
equals 121.
Now remember, this is different. That's why we go back to our formula sheet. We're not using the formula that has the times 100 at the end. We're using this formula. But our new was goblins. Our percent was 20% more, which, well, that's actually 120%. And the previous was wizards. But remember, this solves slightly different because the thing we were able to fill in for is the number of goblins. Now, actually, I'm missing a money down here because the song goes, money, 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 money. Anybody? Nobody? It's an old, like, funk song. Let's talk about money. Can I not, or can I know? Because I know a lot of things.
Wait, since when have these lights been?
The whole year.
Yeah,
You're like the 12th student to be like, wait, when did you get these? And I had to be like, I've had them.
No, you haven't.
Fight me. I have.
No, I don't think I ever looked.
Go back to some video previously when I picked my camera up and turn it around. I guarantee they're up there. They've been there since last year. I got in trouble by the fire marshal last year and then had to rerun them with no extension cord. So notice they're plugged into an outlet in the ceiling. No extension cord, though, which is what I'm allowed to do. All right, math. Neil. Oh, my battery's low. Go figure, another problem about a board game. So Neil buys a board game. He paid $1.54 in sales tax.
Oh, I thought that meant total.
No, we got to read the problem, guys. The tax rate where Neil is 5.5%. Now, we might have to go back to our formula sheet. If we are like talking about just tax. Just tax, right? I would go back to your formula sheet and say just tax.
Can I write down the formulas? Because I didn't get them.
Yeah. I mean, you can always do this later, too, like AO extensions, whenever. You can just come borrow my paper, too, if you need. If we're talking about just tax, the tax dollars will be equal to the tax dollars will be equal to the percent of tax times the original price. Or you could just say price. I mean, so the money for tax will equal the percentage for tax times the price. So if we go back to this problem, and I can even fold my paper so you guys can still see that formula. How much did he pay in tax money? It says it in the problem. It's in the problem. So I wrote again, just to have it written again, tax is equal to the percent times the price. They tell me the tax is $1.54. They tell me the percent of tax is 5.5%. The thing we don't know is the price, so I'm going to call that P. Can I use 5.5 with the percent sign?
Nope.
Ah, darn. Gotta do the swoopty. Yeah, to the left, which means we have to add an extra 0. Does it make sense? Stop me if it doesn't make sense. So I will off to the side write what we did. Right, we did that 5.5% is 5.5 over 100. And to get that to be over 1, so we can actually use the number, this becomes 0.055. Because this decimal bumps twice, so this decimal bumps twice. And that's why we have to put the extra 0.
Oh, okay. I was starting behind the decimal, so I was reading the 5.
Yeah, it's not 0.55, it's 0.055.
Okay.
So now somebody else out there, do this division. I don't want to be the only one using my calculator. We got to make a giant 1 because this is multiplied by p, so we got to turn that into 1 by putting it over itself. But that means we have to do that division on the other side as well.
How do calculators know, like, every problem?
I mean, we taught them, we programmed them, right? Humans or mathematicians or whatever you want to say, programmed them. Guys, if you want to start learning about writing code in Khan Academy, there's a thing called like Learn to Code or like coding in a box, or there's a few different coding things. Go check it out. 1.54 divided by 0.055, 28 it looks like. So P, the purchase price of the game, is 28. And that would make sense. There's actually no sense. It's all dollars. Now, the problems you will more likely see, I mean, you'll probably see at least 1 or 2 of those on the mastery, but something like this. Try to calculate this real fast. We got a couple minutes left. I'm going to walk around with wipes while you guys think about this. The dinner, just the food. Now, I know we said we don't pay tax on food. You pay tax at a restaurant because it's a restaurant, and you also pay a tip, right, because it's a restaurant. So even though we don't pay tax at like the grocery store, we pay a tip here. Her dinner was $45.
Jeez,
Well, it might be on a date, might be a couple people.
That's disgusting. That's
Natalie, that's the world. I go on dates with like my guy friends. A date is when you plan something. A date does not have to be romantic.
That day was like a smoochy smooch on the calendar.
No, that's called a kiss, Nate. A smoochy smooch.
That's like, are we in your
Hey, I don't know why you put stuff away. Didn't I just tell you to solve this?
Can I use the same formula?
We can, because the dollars in tax formula is the exact same thing as the dollars in tip formula. And this is why I wanted us to solve this problem before you leave. So if we need to calculate the dollars of a tip, that's going to be the percent of tips that we want to leave. And that's up to us, right? We kind of choose that times the food price, or like the dinner price, or the bill is normally what we're, like they hand you a bill and they say you have to pay this much. Anything over that is you being nice.
I don't do that.
So in this situation, we need to calculate the tip. The percent they tell us is 15%. They had decent service. Maybe it wasn't amazing. The bill was $45. Can I do the math using the percent symbol?
Nope, you gotta.
Nope. Nate wants to do the smoochy smooch.
No, you gotta do this. I did not mean to say save it for your girlfriend.
So 0.15 times 45. Again, grab your handy dandy calculator. I mean, you could do this on paper probably. Now hold on. When you type this in to Khan because you get excited that you got an answer, it will spit back that it's wrong. Why, Lacey, will it say it's wrong?
Because it's asking for her total bill, not just the
So I would like put a star or some sort of alert. Total bill amount. Now I know they'll like use the same word, I don't like that they're saying total bill, but total bill is the bill plus the tip. My uncle's name was Bill. So 45 plus 675. What is their total they're going to pay? 50. Yeah, 51.75. Please go ahead and wipe, put your things away, wipe off your desk, and we are good to go.
Good night.
Not really good night. It's 10 in the morning.
Morning. Really? It needs to be lunch already. I'm hungry.
Those of you at home, please catch up on Khan Academy work. Announcements for everybody. I promise you, the work you're doing in Khan Academy will be more difficult than the test I'll give you on Wednesday. I know the Unit 2... The Unit 2 test was kind of challenging. I get that. I have them. Most of us got progressings, which is just always what happens because we have high expectations. We did have an exemplary. We did have at least one mastery in here, but I will give these back to you on Wednesday because we're way out of time. We're way over time. If you really want this back at AO or extensions, come see me.